next up is the long-awaited panel. Where is everyone? Is everyone here? Everybody in the panel checking in? Mike, you back? You back, man? Nobody's coming? Where are you all? Where is everybody for the panel? Nobody's here for the panel? Where are they? In the meantime, this thing that you see on the screen, this was what we were talking about. All right, now some people are showing up. I like to see that. So what you see on the screen, just here, scan the QR code if you're interested in talking with people from Tecton. And look at that. We got some people on screen with me. I'm going to stop this this screen share, and now I can see who we've got on screen. Hello, everyone.
Hello.
Hi.
Hi, Demetrius.
What's going on? Good to see you all.
You got a great haircut.
Thank you, sir. I am actually going to be getting my mustache fully cleaned up while you all chat about recommender systems.
It's a good timing that you picked for your barber.
My barber is learning all about recommender systems. He's going to change his job, and so I'm waiting here. I'm not sure what is going on and why we're calling Mike to the stage. Calling Mike to the stage because I think he's going to be the one that is going to be doing this. If you guys want, I can do it for you. I mean, I could start chatting about some stuff and we can get into it. I mean, what we should probably do in the meantime, because like any good online conference, if there weren't any technical difficulties, it wouldn't be a real online conference. So let's just introduce ourselves, shall we? I'm Demetrios. I am here in a barbershop. What about you? Who wants to go next? Krystal, I see you next on my screen. Can you tell us a little bit about yourself?
Hello, I'm Krystal. I am based in Bristol, UK. Right now it's quite dark. Everyone else, it seems like the morning for them. Lucky you. Yeah, I work for Cookpad. We are a recipe sharing platform. It's also a cooking community. We're trying to make everyday cooking very fun. So if you really love cooking or you're trying to learn cooking, please check us out.
Incredible. Oh, look, the moderator has joined the chat. What's up, Mike?
Hey, everybody. Sorry, I'm late.
Welcome.
I thought we were starting. I think the timing's off here. Okay, are we good? Are we rolling?
Well, we were just doing introductions because I think we're missing one still, and I think Jacopo is en route. So we just heard about Krystal, and now maybe we can hear about Agnes.
Sure. Hi, I'm Agnes. I'm based in Berlin, Germany. And yeah, I'm data science lead at HeyJobs, which is a job talent matching platform in Germany. And our aim is to become the LinkedIn for blue collar workers. And yeah, I've been working here for more than 1.5 years on mainly search and recommendations, automating pipelines, etc. Yeah, and before that, I worked in several other companies, small ones, large ones, also mostly on topics of ranking, search, and recommendations. And yeah, my background is also related, as I studied artificial intelligence in the Netherlands, where I'm also originally from.
Awesome. All right, Mike, I'm going to hand it over to you, man. This
Cool.
is yours.
Thank
you want to
you.
go through the intro?
Yeah, we're starting a little bit early, so this is great. Thanks, D. And let me see the flow right now. How are you looking? They haven't chopped off too much, eh?
No, but
they just got this part. But I thought you're gonna buzz the whole thing.
No, buzz, man. What are you, crazy? No, that's not that wild. Okay, I'm gonna drop
thanks,
off.
D.
I'll let you guys enjoy this.
Awesome. Well, hey everybody. So thanks for joining me here, and I'm excited to have this conversation with you. One of the things that we've talked about so far in Apply, and something that I think is like a question that a lot of people are dealing with, is the fact that there's a variety of levels of sophistication that recommender systems can be at, and they all have different levels of capabilities, and they all come with different costs. It can be, so, if you're getting started in recommenders, you see all these different complex things. Even like look at some of the talks we just saw. It's really tricky to figure out like where to get started. What of this stuff do I apply in my own company? What's relevant for me? Stuff like that. So I kind of just wanted to have a conversation about just some of the more like applied practical sides of building and deploying recommenders today. So, I mean, I can start it off with actually, I wanted to start off with Jacopo and Agnes and just talk about like recommender systems. What's particularly challenging about doing this in an applied sense that's different than when we think about like theoretical, you see someone give a talk or a blog post about it. Like when you do it in practice, what's particularly challenging, and what are some of the more like common gotchas that teams run into as they're implementing this stuff on their own?
So thanks so much for the question. My take is recommender systems are much harder than people think, because the gap between the typical movie lens tutorial with matter factorization and then what actually happens in the real world is actually farther along. It's actually bigger than in other cases. There's a bit of a gap between the usual, churn or classification example on toward data science and the actual thing, but the gap is significantly bigger for recommender system just because of all the moving parts. So I think that's a given. My experience, the biggest problem is always the data, and that's a general thing that not just for recommender system but for all ML systems. A lot of people want recommendation, but then you need to ask yourself, do you have the data to turn your business problem into a recommendation problem? Are you tracking properly user interaction? Do you have enough metadata about your books or movies or jobs or whatever you're recommending? And in many cases, the answer is no. I think there's not even enough data to even ask the question as a recommender system question. So I think a lot of people jump into the modeling aspect, in my experience, but then there's a broader question like, hey, do we even have the entire feedback loop in place for recommender system to be successful? So that's for me, thing number one. Yeah,
that's great, and that's a theme that, I mean, obviously at Tecton we talk about that all the time, like this completing the loop, get the feedback loop, get your kind of like your data, get your data into place, and then what are like some of those kind of key questions that someone should ask themselves when they're trying to say like, hey, do I have my data story together? Like, what should they look for?
Can you join deterministically what your model does with the training data points that got into that, with the thing that the user click on, with the metadata on that item? If you can do that with with 10 seconds, you're good. Like, you have everything you need to do to be fantastic. And most people will take a couple of iterations for most people to arrive at the point of having this single source of truth for the event. And of course, there's a million ways to do that. And thanks God, 5 years ago, there was no tools or no companies that would help you do that. Now, honestly, the things have changed a lot in the last year or so.
Awesome. Agnes, what do you think? What are some of the kind of like common mistakes that a team like yours might run into that you think everybody should watch out for?
Yeah, I would in general agree that the main culprit is the data, but maybe to add to that, some specific cases that I've seen in practice is mostly related to iterating very long time offline before actually A/B testing the model online. And in this case, for example, it turns out that the data used for offline testing was not really representative of the actual business metrics used for measuring performance online. For example, the data was really on a small subset of all data, or it was too old, or it was representing a completely different metric. What I've also seen is that, again, related to iterating very long offline, is that people really focus on building the model, but then they sort of delay the entire architecture to the end. So then when it turns out, when the model should be deployed, it turns out that this is not easily possible because it's too resource intensive. And one particular case I've also seen, also related to this, is that people do have the data and they do have a sensible model offline, but they simply forget to incorporate some business logic such as paid ads, etc. And that also then only pops up when I do online testing. Yeah, those are some common issues I've seen.
So like just to kind of like summarize the themes there, you're basically saying like it's really common to overweigh or overemphasize the offline experimentation to the detriment of the kind of like the success of the project, because then you kind of try this thing online and it's different than you expected, and so that online and offline parity, or at least being able to validate that things are working as expected online, is something that people often kind of like don't see coming or don't prepare enough for. Is that right?
Yeah, exactly. I think they underestimate, all the different factors that make up a good alignment, basically.
Got it. Okay. And so what do you recommend? Like, if someone, if there's another Agnes starting off at, like the next like HeyJobs 2, right? And they're taking on this recommender system project. What advice would you give them for how to actually like test stuff online, or kind of like de-risk that kind of pitfall ahead of time?
Basically two things. First, do really good analysis on your data to see what it actually represents, kind of related to what Jacopo said. And second, to really, bring the model online quickly. And also, in the first stage, I would start with really focusing on getting the whole flow right, so the whole end-to-end pipeline right, and maybe deploying just a simple model, and then just basically iterating over that with regular online testing.
Cool. Okay, great. And I also wanted to mention for those who are watching, feel free to add questions in the chat, and then we'll get to some of those along the way as well. Let's kind of switch a little bit topics when we think about to thinking a little bit about like some of the options that people have when taking on a recommender system, right? So so if I'm a new team and I'm like, hey, I need some recommendations. There's products who are like, we will deliver recommendations for you, or I could go and build a recommender system, right? And so there's pros and cons, there's benefits and costs to each of those, and there's a lot of people. There's these companies, like these recommender companies, for example, like a product like AWS Personalize, which are like, just plug in your data and we'll handle all the recommendations for you. Krystal, have you kind of dealt with that? How did you make the decision of like, should I build or should I just buy like an end-to-end recommender system? From your perspective, how have you thought through that?
Thanks, Mike. We did. So currently what we have is an in-house solution that we build. Truth to be told, when we were looking at recommendation systems, we didn't really consider like AWS Personalize, even though we are on AWS. But just from experience, I think building your own in-house solution means a better control of the system and the model. And then that equates to better visibility of the model as well, and then easier to debug when something goes wrong, and also fine-tuning any part of the stack where needed. However, that being said, is because we have a very established and nicely working components and infrastructure system in the company, I can see that if you're a company or an org starting out doesn't really have a lot of components working or well integrated, then maybe a well-managed third party or AWS or Google or anywhere, a service like that would be quicker and easier to just plug in and test things out. But yeah, that's what I think.
And can you share a little bit about like the rough, like how mature was your team when your team decided, hey, let's actually build this thing? Like do you have a 2-person ML team, or do you have a 20-person ML team? And kind of like what was there? Sure. And did that end up being a good decision?
Yeah, so when we started out, so the team right now is about 4 to 5 researchers, and then we have 2 ML infrastructure engineer who we have a very good, dedicated to building a very reliable machine learning infrastructure platform team. So we have, so when it comes to running batch jobs and then developing services and even looking at the data, we have all the resources for that. And the reason why we went for in-house solution is that we also had all the embeddings available already so we are a recipe service. So recipes, user data, So we have a lot of data to begin with. And second of all, we've been building all the other features that utilizes NLP, which means we have good embeddings. So we went for a very simple and direct solution. So we use similarity search, and we wanted a quick and direct and easy solution to begin with. So as Agnes said, we can test things out quickly online so that we can validate the feature and see if it adds any value to our users first, instead of diving into finding the state-of-the-art solution and then ended up wasting a year, and then ended up that feature doesn't really work. Then yeah, it's just effort down the drain.
That's interesting. So you got a small team, and you took the approach of starting small as well, but it was still a good idea for you to build your own system and for you to maintain that own system. That's really cool.
I think because I think it's a lot more flexibility for us, that we can use any tools or any models that we like, and then to plug it in. So it's quite nice. We have we let researchers have the freedom to do that.
That's great. And Jacopo, any advice for people thinking about building the build versus buy, like in a complete black box end-to-end solution?
I mean, I'm notoriously on the far end of the spectrum, the buy. So everybody in the MLOps community love me because I always say to people, buy stuff. So I'm kind of like a poster child for the entire market. But as a person that was that was working for companies selling information retrieval APIs, of course, it may comes off as a bias thing. My argument is always the same. If your business depends, like recommender systems are by far the most ubiquitous machine learning system at scale on Earth. The recommender system market is going to go to $50 billion in a couple of years, according to recent projection. So recommender systems are a big deal. And in one way or another, everybody has one or some further recommendation. But it doesn't mean that everybody core business depends on their recommendation. So my argument is always the same. If your core business depends on how good your recommendation are, even now or in the near future, build it yourself. If not, just buy by somebody that has, recommender system people that build it for you, because it will save a lot of pain to do that. I think there's a lot of intermediate, like again, this is a continuum. It doesn't mean personalized. There's simply that are a bit low level that you can still use. And there are open source platforms that are like in between build it yourself, but something already made. Like I'm a huge fan of NVIDIA Merlin as an open source tool. So you don't have to pay anything. It's open source by NVIDIA. But of course, it gives you some of the building blocks that you don't have to build yourself. So when you fall in that continuum, depends on your skills, time, and a bunch of stuff. But generally speaking, if recommender system is not your thing, buy or start from somebody else's work instead of reinventing the wheel.
Yeah, and I think I see this like repeatedly, right? I think this is a common set of decisions that companies who are implementing, they're building ML in their company, they have to think about like, what is actually strategic for us? Like what, if you're the TikTok folks that we just heard from, right? Like they're not buying a recommender system, right? That doesn't make any sense. But in some cases, it's not just as simple of a question as is recommenders strategic or not strategic for us, but it can be, is this infrastructure, do we need to be experts at the recommender infra, or do we just need to have the right do we need to, is like the kind of algorithmic side or the feature side or the details of our recommender strategic for us? And so you can kind of break it down beyond just like the simple, is this whole system strategic for us? And so when someone thinks about like, what size of an ML team am I, and am I able to do I have the capacity to take this on or not? Like how do you think about like the various stages? Can you break down that like continuum for us between build everything on your own to just buy a complete black box solution for someone who's not familiar with some of the different kind of like offerings or different ways to mix, build, and buy along the way?
Sure. So I think on the far end of the spectrum of like completely hands off, I don't want to have anything to do with it, there are the typical B2B SaaS provider like Algolia, Coveo, Lucidworld, Bloomreach, all the Gartner quadrant, so to speak. And the idea here is that we really don't want you to deal with this, as in you want to offload it to somebody whose main job is to build a good recommender system. There's a few API, just send us our data and somehow we figure it out. There's even pre-made UI. You don't have to do anything. We're going to give you the carousel. embed in your page. So you literally don't have to do much. So I think that's the most hands-off thing that you can do. If you move a bit closer, like to the left of the spectrum, you're going to have stuff like GCP or AWS personalized. So the typical cloud provider thing. They're still black box, but they're a bit lower level than the devoted platform. So I don't think a business user would be able to set up AWS personalized or GCP itself, but they're still kind of black box. Like all infra or algos are completely abstracted away from you. Then you move away one notch, and you're going to have the open source platform, as in Merlin, TensorFlow Recommender, PyTorch Rex, and so on, or a million others. So the algos are abstracted for you. So you don't have to invent what a recommender system does. You don't even need to know what a two-tower system is built upon. But now the infra is yours to build. So now you have to take on the responsibility of training this and running this. And then on the very, very far left of the spectrum is, well, this is PyTorch. Have fun with it. and you have to build the entire things yourself. My argument is that there are basically nobody on the left side of it, unless you're Etsy, okay, or Spotify or whatever. People like me will be on the between the left side and kind of Merlin side. But then the vast majority of people, my recommendation is to be on the right side of this invisible line, at least to start, because that's a crucial aspect. You can always go left, but it's very hard to go right. If you upfront all the cost, now you spend all the money without knowing things. While if you start easy, you can always get bigger as you get more appetite for it. So always go right to left in this imaginary line and never on the other side. So start simple and something you can buy. And then if you have the capabilities, the data, you can always put it in-house. It's much harder to do the opposite. Work 1 year on a project and then ditch it to go on AWS personalized. You won't look good on your resume.
Yeah, it's funny how like kind of not, it sounds kind of like a cliche to start simple, but it ends up being like the most useful advice, and no matter what, people don't follow the advice. But it's actually like a really important thing to keep in mind. It's so easy to kind of skip over that. And you know, as part of this different, like these different spectrums, there's different levels of infrastructure that you need to build and maintain. And so I wanted to kind of like talk about with us like some of the different pieces of infrastructure that we are building internally. Marc, do you mind telling us a little bit about like how do you guys do recommenders? What's your use case? What are you guys recommending? And then like, what are the systems your team maintains? And was that a good choice or not?
Yeah, cool. So we basically, our idea was essentially that we wanted to like personalize the entire lifestyle sector for users. So we pull in like loads of product catalogs from all these different platforms, ranging from like Ticketmaster to Spotify to Netflix, OpenTable, you name it. And then we basically personalize it to you. The issue was, or what we very much noticed, and we actually tried the kind of like buying thing at the beginning. The problem is that we have like an insanely context-driven recommender, right? So a recommender can recommend something for 2 people or just for 1 person, but it's also very based on like, okay, I want to do something right now, right? So now you suddenly need to wait. Like we have then special location scores, like how far will you walk? But it's also then city dependent, right? So like, I don't know, in Atlanta, because everybody drives, like 15 miles is not that far, but like in New York, it's quite far. So we have all these different things that are extremely context driven, and that made it really hard. I think in multi-model, what we have a kind of multi-model approach. Yes, I think you can take a certain model and kind of outsource that and pretty much say like, hey, that thing, you know, that's pretty standard. Like I would say like your average kind of collaborative filtering model, right? Like a lot of that can kind of be outsourced. But the really context-driven part where you really need it to work like that is really needs to be built in-house. And then you also really run into problems because feedback loops always sound really simple, but they're actually really complicated, especially if you're an evolving product where the recommender system is so hard. So like our users really only interact with our recommender system. Like they download the app because they're getting recommendations.
Yeah.
Right. And so we have things like a favorites button or a share button or stuff like that. And so let's say someone decides to move it, so the rate goes down. So like, have the recommendations gotten worse, or is just the new UX placement different? And then also, how do you record that in the data, right? That's so hard. Like, how do you tell an ML engineer 1.5 years later who's like, hey guys, like 1.5 years ago, like you really messed things up because people didn't do this anymore. And you're like, yeah, we removed that button, right? And how do you put that there? So that's, I think, something that we work with a lot. But I think a really big game changer for us from a model perspective were very large embeddings. Like that really helped us, because suddenly you're able to just like take these massive amounts of descriptions that you have or reviews, etc., for example, a restaurant, and you're just able to compare it to a restaurant that is in a completely different city that no user has essentially ever seen of yours, but you have a lot of text or a lot of image. And so you are able to compare those two. That has like made really big differences. And so yeah, we have about 7 different models kind of that look at different things. We have a pretty similar setup than what you described in your start. So kind of candidate extraction. So that's a kind of just what candidates we have. Then they get kind of reduced a little bit, scored, ranked, and then returned to the user.
And can you talk a little bit about like the infrastructure for managing the embeddings? Because that's pretty new for a lot of folks as well. Like, what are the actual systems you build? Are you processing the embeddings once a week or something and then loading them up into an online store, or how do you guys do it?
Yeah, really interesting question. So we have 2 parts there. So we do most of the first embeddings, we do purely offline, and that run with a data pipeline. So we have a pretty sophisticated data pipeline that essentially pulls in like images, text, etc. So for example, our image, like that is all stored in first on S3, and then actually really kind of quite unusual, but in a Postgres database. Don't ask why, but it works. We tried Pinecone, but what we just noticed for a small team is like, yeah, you can get all these like perfect solutions, but you have more and more things to maintain. So what we just opted for is like, because that anyways gets pulled into the recommender, and then it's anyways recommender code that takes it, and there's no operations being done in the database. We did try Redis. Redis has a really cool new thing for embeddings and stuff like that, but we just noticed that like it didn't actually help that much, or like didn't really change our use case. But it's essentially offline that creates all the embeddings, and then live all we do is sometimes that we average certain embeddings. And we also found that like clustering embeddings is like insanely, like anyone who has a lot of text or images, guys, like try clustering it. It's crazy. Like you will find things in your data that you never thought was there, and let an expert look at those clusters, and you will find things like you will
What's an
find.
example that popped out to you?
We found, for example, that it was able to identify restaurants in hotel bars. Like it was literally, we found one cluster, or we always really struggled with finding bars where you could do something outside of just drinking, meaning like, I don't know, play darts or play, and it literally just found a cluster across the entire US of things where people described that they did things that were outside of drinking,
Oh,
right?
that's really cool.
And it wasn't possible for us to do that before, and it was so hard, and we literally just clustered them. We got like 450 clusters, and we went through them with experts, and we literally just said like, hey, this, like, compared all these different places and found like, hey, all these places seem to be in hotels, all these places have, I don't know, pool tables, right? And so
And can you also just let people know like your team, like how big is your team? Because it's always one thing that's really interesting is like people will say different things that they've built, but I think another challenging question for like a practical teams is like, is my team set up? Is that something that's possible for my team to do with my 3 people or 1 person or 30 people? So your team, kind of like, what scale are you guys talking about? And then that may help people understand like what's possible for them.
well, with recommender system, that's always difficult to say, because as you said, like feedback loops are important, etc. So like, do I
Yeah.
count like a backend engineer that just saves what has happened to the database? Probably not. But like, I would say we are about 3 people in like pure ML part, or like the recommender part. but then we are like 5 to 6 people that are really like on the data pipeline. So they actually make the whole thing kind of work, that give the kind of the juice. And then you have to, though, very much look at like, okay, there's a lot of database stuff, a lot of this stuff that kind of runs in between, but it's not really one team.
Awesome. And Krystal, you were laughing a bit. Do you guys do some clustering too? That was that ever useful for you?
No, I actually wanted to ask, so the embeddings, what type of data did you use to build embedding? Just kind of curious, can you draw any correlation between like what data did you use that it could actually identify these are restaurants and bars?
Yeah, so I mean, for you guys, like with recipe, so if you, for example, I don't know which model you use to create embeddings for your textual description. So let's say use something like BERT or something like that, and you create an embedding. What we then used, I have to look at it exactly which clustering algorithm we use, but essentially it just clusters the embeddings that you have. We used a soft clustering technique because it allows you to put things in several clusters with certain probabilities. So like, for example, a recipe could be part of vegetarian, but also part of like Asian, right? So, but you don't want it, like if you force it to just be in hard clusters, it will just be in one like this. You can actually say like, if it is also with certain probability falling in that other cluster, then I can say that it's both Asian and vegetarian. But you kind of need to create your own categories if you have those. As kind of features. So we use them, we like map cluster IDs to our internal categories and kind of say, if it is part of this cluster, then it is also then you can assign this category to this venue, for example. So with movies, Christmas movies, for example, was one of the biggest clusters, like it was just a really big cluster. And so we actually started creating categories based on what we internally didn't know from a product perspective, what was important to people.
Yeah, you're discovering the categories. That's really cool. And one theme that like we've seen people do that clustering, but then they, or even like in doing these embeddings, but computing these embeddings even in real time, sometimes taking into account, like you mentioned, a lot of the context. That's really important. And it's one of the things I mentioned earlier on, like recommender systems that can take into account the real-time context, that taking into account that context can be crucial for a recommender system to be actually useful in certain use cases. And so it's kind of this interesting thing about like when is real time and when is context being taken into account in real time useful for a recommender system. Agnes, I wanted to kind of ask you about, how do you think about whether real-time data is kind of a trend of bringing that into recommenders, whether that's useful? How do you know when that's beneficial? And how do you think about like making that move? Do you guys use real time in your recommender? Is that a direction you're going?
Yeah, actually right now we aren't, although we are kind of moving towards it. So I think real time can be super beneficial if you're really making recommendations, providing a user with recommendations while they are, for example, browsing the platform, right? So let's say they watch an item and then immediately thereafter they can get the recommendations. Yeah, for us, we are right now not at this stage yet. So yeah, we do have some recommendations on our platform, but they're not really based on actual user actions yet. We do have more scheduled recommendations, basically CRM emails. So for it is not really a necessity at the moment. To really make it live, but what I also might add is that yeah, we've also some kind of different considerations when it comes to real-time or batch data ingestion for really, getting always the latest data when you do these batch recommendations. Basically, we have some data that's ingested real time that's more important, and then data that's sort of updated less frequently. Yeah, we've decided to go for a more batch-based approach right now, and then we might later make it more and more real time. So yeah, again, really an iterative approach. to give
Cool.
just an example, when we recommend jobs to users via email, then we always use the latest application information, so the latest job they apply to, and also the latest information about the job itself, if it's actually still published or if it's already unpublished. You don't want to recommend those jobs. But we also have some information about what jobs they bookmarked, for example, but bookmarking occurs like 10 times less frequent as doing an application. So we don't do real-time ingestion for that right now, as it's simply not a priority.
Got it. And and one of the things that so in a past life for me, I helped create the ML platform at Uber, and we helped support a lot of the different teams to move to put their first ML applications in production, but also like to tackle this question of like, should we use real-time data for this? It adds complexity, but it can also have a disproportionate improvement in the impact of the application. And so, Jacopo, for you, like, how do you think someone should think about evaluating if real-time data is useful for their recommender? Recommenders are already hard to evaluate. How should someone determine and think about, should I go real-time or not?
The usual deal is there what people do now informative enough for you to make this switch? Like, consider the typical use case is like, hey, I textbook use case is the Netflix one, right? Netflix knows a lot about you. So it turns out, because you're subscribed, you're identified by that, you've been there all the time. So honestly, if they compute the recommendation once every night, it's called offline training, offline serving. It's probably fine enough for most use cases. At least you will get them a lot of mileage out of it. But now think of an e-commerce that is on Amazon, is a normal e-commerce. You may or may not know, but like the vast majority of people never register to any e-commerce that is not Amazon or Etsy or whatever. And the people never come back to the same e-commerce more than twice a year. Which means that if you're an average e-commerce, you have no idea what this person wants or does. You have no idea what this person purchased in the past, because there's no way for you to connect the behavior of this session to anything before. So in that case, the only thing you can do is going online. Like, if the only strategy you have for personalization, a lot of vendors talk about personalization, but if the only strategy you have relies on having an history about the user, you're going to fail in the vast majority of cases, at least in e-commerce. So you should think of moving slightly to understand what people doing online. And so remember, so the textbook is offline training, offline serving. And the second part will be offline training and online serving. So it doesn't require anything to update in real time, but requires you to keep track basically of the position of the user in some latent space to inject that context when you make the prediction. And then the full real-time online training, online serving, basically nobody does. It's the equivalent of viewing recommender system as a reinforcement learning system when you literally continue training that. But it requires a completely different level of sophistication and understanding of the problem that is beyond the scope of basically 99% of
Yeah, for sure. And Marc brought up a really interesting thing where he was saying, and this is a thing we dealt with at Google. He was saying, like, hey, you have, what is the data that your users interact with? It's your recommendations. So, you're only getting feedback on the things that you recommended, and so then that affects what your training data is going to be for your next version of that model, and that's a feedback loop that can have a pretty big impact. And I worked on the ads team at Google, and we ran the recommender models. And that was something where at that level, we were retraining models really quickly. And that kind of feedback loop became a very prominent thing that every engineer had to worry about, is how do you manage the feedback loop and make sure that you're not overfitting to the recommendations generated by the previous version of the model. So there's a lot more of like higher order problems as you increase the sophistication of your model. You deal with kind of like newer problems arise. So that's why it kind of can be harder and harder to improve the sophistication of your model. That's kind of interesting that you touched on the same thing. And let's just kind of finish it off. Like Krystal, Marc, how do you guys know if your thing's working? How do you know if your recommender's on track? How do you measure its performance?
I mean, there's offline and online, right? You use the offline metrics to evaluate model, and usually you kind of have to pass that bar before you bring it any further. But I really want to emphasize on online metrics or business metrics, because there's often, Agnes talked about earlier, is that there's often a gap between offline and online. We've had experience before where we develop something in theory that should bring up a lot of user interactions. However, when we actually release it online, we're not really getting the CTR that we wanted. But when we investigate further, it turns out people are not even clicking on the feature that we developed. So that turns out it's a design problem that we didn't know, because offline there's no design, right? Like, we assume that all the users want to click and then want to interact. So I think a very important thing to bear in mind is for all ML project is that to make sure that you're in line with the business metrics, and also be clear on what kind of business metrics you're trying to measure when you're developing the model as well.
Yeah. I think from our side, I think first of all, it's incredibly hard. Like, it sounds simple, but like actually knowing if your rec system works is probably one of the hardest things that exists. For us, for example, really hard is, like, let's say somebody says they want to go to a concert tonight, right? And we see this a lot. Like, we even had users during COVID like ask us they want to go to the cinema, and then we're disappointed when we couldn't give them cinema recommendations, right? So you notice often that like a user says, I want to go to the concert tonight, and there's like not a great concert on, so they don't get the best concert. And we clearly, for example, even show them a matching percentage to show them like how much do we think this matches to, and even if that's low, we often notice disappointment. So we kind of always have to look at a little bit like, out of all the things that we thought he could get, how good was that actually? And then we actually need to weigh that against the what he actually did in the end. So like, do we actually think there was something there that he would have liked? Okay, now did he respond positively to it? If yes, then that's a success. But if no, then it's also not a kind of not success, because the pool of candidates is just limited, right? So it's a bit different to a kind of infinite pool of things where you don't really have to worry about it.
Yeah, and I think this touches on some of the thinking around like, when do you buy a solution versus when do you require the flexibility that comes with building your own solution. And in this practical example that you're talking about, like, there's not going to be an out-of-the-box solution that has that exact evaluation function that you just described. So this is an example of one of those times when you need to kind of implement this evaluation function on your own. And when we talk about, is this strategic to you or is it not, like, that's the kind of thing that's strategic to you. You need to be like implementing the exact right objective function for that corresponds or approximates to value for your users. And you're not going to find that in an out-of-the-box solution. But maybe you don't need to be an expert in candidate generation. Maybe you can use something out of the box for that. So I think that's kind of like a really nice example to end things off with. Folks, I want to thank you so much for participating here. This is a really cool conversation, and just trying to make it like as useful as possible for anyone who's listening, who's at different stages of this journey, to kind of get a glimpse of what things look like practically at different stages. So Krystal, Marc, Jacopo, Agnes, thanks so much. And I think we'll move on to now a really interesting workshop coming up. I don't know if Dimitrios is going to hop on, but coming up is a really cool.
With a new haircut, maybe.
Oh yeah. Dimitrios, are you hopping on? I want to see his snip.
Oh no.
I want to see this guy getting a buzz cut here. But thanks, guys. Just a quick plug for me for the next session. Jake and Danny are going to be talking about practically doing an example for recommenders. But Jake just published a really awesome blog post about recommender systems and the different components of them. I'll probably plug that at the end, but check that out. That's on the Tecton blog as well. Okay, Dimitrios, over to you, man. And I want to see exactly where we're at. This is the longest. My haircuts take 20 minutes, and this is the longest session I've ever seen.